أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم. Please like, subscribe and share my YouTube channel with others so that they can learn mathematics very easily. Mathematics is a really easy subject, but people have made it very difficult. After this video you will see that mathematics is really easy. And knowledge sharing is a virtue, so you must share my YouTube channel with others so that they can learn mathematics easily. You have to just forward. It will not take a big time, but you will get reward from the Allah. Now we will start FSC 2 chapter 1. Chapter name is function and limit. Exercise 1.1. We are going to start question number 4. Find the domain and range of the function g defined below and sketch the graph of g. Function name can be f of x, g of x, h of x, r of x, p of x, whatever can be the name of a function. Here the function name is g of x, and we will find the domain and range of these functions. There are 8 parts in this question, and I will tell you the types of the function also in the question, as it is not required in this, but I am giving you the extra knowledge. I am telling you the types of the functions, name of the functions, and then I will tell you the domain and range of all these parts, and we will draw the graph as well. So let's start. The question. Here is the function g of x is equal to 2x minus 5. As the power of x is 1, if power of a variable is 1, its linear function and its domain and range, you have to learn for whole life that its domain and range is set of real numbers. Domain and range both are real numbers, and set of real numbers can be written as a letter R with a line R. If we write simply R, it's an alphabet, but if we will mark a line with it, it will be called set of real numbers. As there is no symbol in keyboard, so we will write R with R here, but in typing there is no symbol like this in the keyboard, so you see that R, but you have to write in exams the symbol R with a line. It will be set of real numbers. There are 3 representations: the set of real numbers in descriptive language, and R set of real numbers, and minus infinity to plus infinity. You can write set of real numbers in 3 ways: set of real numbers in descriptive language, or with the line it is also denote the set of real numbers, and minus infinity to plus infinity. Here are 3 symbols of set of real numbers. As I've told you that this is a linear function because power of x is 1. If a variable has power 1, it's called real function. Linear function, and its domain is set of real numbers. Again, I'm telling you that if it is a function in which variable has power 1, it's linear function, and its domain is set of real numbers. as I told you that set of real numbers can be written as in three types, in three ways. If you have to draw the graph, you just need 2 points for the linear function. But as I am going to tell about the domain and range, so I have put some values in a table. The value we will put in the function is domain. These are domain, and the answer will be range. These are answers of putting the values in the function. These are domains and these are range. The value we will put in a given function, it is called domain, and the answers you will get are range. Input is domain and output is a range. Now if we will put -3 here, 2 into -3, that is -6, and -5 will be -11. There is no need to tell you about every point, but I am telling you, if you will put -2 here, 2x minus 5, you will get -9. If you will put -1 here, 2 into -1 minus 5, the answer will be -7. If you will put 0 here, 2 into 0, that is 0, and 0 minus 5, answer will be -5. The values which are we are putting, these are domains and these are range. If we put 1 here, 2 into 1, 1, 1 minus 2 into 1, 2, 2 minus 5, that is -3. If we put 2 here, 2 into 2, 4, 4 minus 5, minus 1 is the answer. If we put 3 here, 2 into 3, 6, 6 minus 5, that is 1. These are domains and these are range. Now we will draw the graph here. As I told you that this is a linear function, we just need only 2 points. It can be any 2 points. You can take these 2 points, you can take these 2 points, any 2 points, you will get the graph. But if you want to plot all these points, you can also plot these points and you will find the graph of this function. Now I am going to draw the graph. This is x-axis and this is x-axis and this is y-axis. So we will draw the graph here. I am going to draw the axis again. This is x-axis and dash means x is negative here. If there is no dash, it means it's positive. Y and y dash, that means y is negative here. As I told you that you can draw any 2 points, so I am taking these 2 points is -3 and -11. X is negative on the left hand side. Here is -3 and -11. You can take scale of 5, 5, 10 and 5, 15. 11 will be here. This is the -3 and -11, and the other point that is I am taking, that it is 1 and -3. Here is 1, x is positive and y is negative. Y is negative 1 downward, so -3 is approximately here. So we have joined these points. So it is the graph of the linear function and it is also always a straight line. Now I am going to part 2. Here is the power of function is 1 by 2. Square root means power is 1 by 2. So it is radical function. And square root is always positive. You have to remember it. Some people will tell you, but mostly people will tell you that after removing square root, there will be a positive and negative sign. It's totally wrong. If here is x square is equal to 4, as the power of x is 2, so it means there are two answers. That's why we write positive and negative sign here. As the power of x is 2, that's why we use positive and negative sign with the square root. But people will tell you that after removing square root sign there will be positive and negative. It's totally wrong. Square root is always positive. If square root 4, that will be 2. It's positive. Now square root of x square minus 4 is greater than or equal to 0. Positive means greater than or equal to 0. If we will take squaring on both sides, square root will be cancelled and we will write x square minus 4 is greater than or equal to 0. Minus 4 will be positive on the right hand side and x square is greater than or equal to 4. We will write. Now we have to find the value of x. As there is no equal sign, here is greater than or equal to 4. If we will take square root, there will be positive and negative sign. But as there is greater than or equal to 4, so x is less than or equal to minus 2 and x square is greater than or equal to 4. We have to write. You have to remember it. If there is greater than or equal to symbol, we will write x square is less than or equal to minus 2 and x square is greater than or equal to 2. It means between minus 2 and 2 there is no domain. You have to check. If we will put minus 1 here in square root, minus 1 square, that is 1, 1 minus 4, that is minus 3 square root. If we will solve it, you know that in square root, if there is sign of negative, the answer will be complex number. It's not real number. So it's not a domain. Minus 1 is not a domain. Answer must be a real number. Answer means range. Range must be a real number. Domain is that value. If you will put it in a function, answer must be a real number. If answer is not a real number, it's not a domain. If you will put 0 here, 0 square minus 4, answer will be minus 4. Here again, in square root there is negative sign and its answer will be 2 iota. It's a complex number, it's not a real number, so 0 is not a domain. If we will put 1 here, 1 square minus 4, that is minus 3, and again it's negative sign in square root, so it is complex number, so 1 is not a domain. If we will put minus 2 here, minus 2 square is equal to 4, 4 minus 4, answer will be 0, and square root of 0 is 0, so minus 2 is domain. Domain's definition in descriptive language that the values which we will put in the function, it satisfies the function. Satisfies mean answer must be a real number. Satisfies mean in mathematics. In mathematics, satisfies means answer must be a real number. Answer should not be complex number. So if we'll put the values in this function, in the linear function you can put only 2 or 3 values to plot the graph, but if there is a power of a function that it's a radical function, you have to put 5 or 6 values in the given function. As I told you in the last part that the values we will put, these are called domain, and the answer will be range. So we will put some values here in the given function. Here is given function is square root x square minus 4. If we will put minus 4 in the function, the answer will be 2 square root 3, that is equal to 3.5 approximately. If we will put minus 3 here, you can put in the calculator and answer will be given. If we will put minus 3 here, square root 5, and square root 5 mean, and square root of 5, that is 2.2. Here is written wrong. And if we will put minus 2, answer will be 0. If we will put 2, answer will be 0. If we will put 3, answer is square root 5, and square root 5 is 2.2. And if we will put 4, that is 2 square root 3, that is 3.5. So we have some values. Now we will put these values in the question. As I told you in brief that before minus 2 and before 2 there is no domain. Between minus 2 and 2 there is no domain. You will put these values in the given function, answer or complex number, and answer should be real numbers. That's why these are not domain. Now we have excluded these values, and in symbolically we will write set of real numbers are minus, here is interval, it's interval minus 2 and 2. If there is a small bracket, it means not included. Minus 2 and 2, between minus 2 and 2 there is no domain, so we will subtract from R minus 2 and 2 its domain and range. As answer is always a positive number, so if we put minus 4, the answer will be 2 square root 3, that is 3.5. If we put minus 3, answer will be square root 5. And square root 5 will be equal to 2.2. And if we put minus 2, answer will be 0. If we put 2, answer will be 0. If we put 3, answer will be square root 5, and that is 2.2. So if we put 4, answer will be 3.5. These values are domain and these values are range. As I've told you that between minus 2 and 2 there is no domain, because if we put these values in the given function, answer will be complex number and answer should be real numbers. If the answer is a complex number, the values which we have put in the question are, that is not a domain. If the answers after putting some values in the given function, answer is real number, the putting values are domain. So we will write the domain R means set of real numbers, and this is an interval which is not the domain, so we have subtracted from real numbers, that is R minus 2 comma 2. It's mean an interval between -2 and 2. These values are not the part of domain, so we have subtracted from the real numbers. As I've told you that square root is always positive, mean answer is not a negative number. As I've written here, greater than or equal to 0, it means answer is 0 or positive. 0 or positive means 0, 1, 2, 3, 4 up to so on. This symbol means include, as 0 is included in the answer, and after that 1, 2, 3, there are so many values. Here is 0, 1, 2, 3, 4, there are so many values up to so on. So write positive infinity, as infinity is not a number, so we'll write small bracket here. It means infinity is not a number. Before infinity there is a number, we don't know about it, what is the value before infinity, so we'll write a small bracket here. It means before infinity there is a number we have to go up to. Now we will draw the graph. Here is -4. At -4 answer is 3.5. This is y-axis and this is x-axis. Y-axis g of x, it's mean y, and here is x, so we'll put x is equal to -4. Here is -4 and we have a value 3.5, so we will mark a point here. Similarly, if here is -3 and answer is 2.2, as I've told you before that there is a typing mistake, so here is -3, value of x is -3 and answer is 2.2. Here is 2.2. After that 2 there is 2.2, so we'll plot a point here, and at -2 it's 0, so we have point a plot here. Now we will join these 3 points, it will be a curve. If we'll put 2, answer is 0. Here is 0, at 2 it is 0, and at 3 it is 2.2, not 4.5. At 2 it's 2.2, so we have marked point here. Now at 4 there is 3.5, so we have point a plot here. Now we'll join these 3 points. It is the graph of the second part. Now we will solve the next part. As I've told you earlier that square root is always positive, it's a radical function, so we will write as x square is square root is always positive, so square root of x plus 1 is greater than or equal to 0. If we will take scaling on both sides, then square and root will be cancelled and we have x plus 1 is greater than or equal to 0. As I've told you in the last part that it's a domain, it means we have values greater than or equal to -1. Here is -1 After that it's 0, 1, 2. There are so many values, and here is infinity on the right hand side, so its domain is from -1 to infinity. We have written here. As I've told you in the last part that there is a number before infinity. Infinity is not a number, so if you write infinity, there must be a small bracket. After -1, there is 0, 1, 2. There are so many values up to infinity. These are domains. This means include, and this means not include. If there is square bracket, it means include. This number is included. Infinity is not a number, so we will write small bracket. And as I've told you in the last part that square root is always 0 or positive. Square root is always positive. It means there is no negative answer. It means there is 0 or positive values in the answer, and answer is range. Here we put some values in the given function. If we will put -1 here, answer will be 0. Here we have written 0. If we will put 0, answer will be 1. If we will put 1, answer will be square root 2. If we will put 2, answer will be square root 3. If we will put 3, answer will be square root 4, and it's 2. And if we will put 4, answer will be square root 5. You can put 4 or 5 values if there is square root function. Now we have to plot. These are domain and these are range. And you have to remember, if there is square root function, its range is always from 0 to infinity. If there is square root function, its range is always from 0 to infinity. You have to remember it. Here we have domain and range. Now we have to plot these values. There is -1. At -1 there is 0, so I have marked this point here. At 0 there is 1, 0 and 1. Here is the point. If you put 1, answer is square root 2. At 1, answer is square root 2. We have point A plot here. Now is 2 and square root 3. The value of x is 3. Here is 3, and square root 3 is 1.7. We have the value of y is 1.7 here, so we'll mark a point here. Now at 3 there is 2. The value of x is 3, and we have a value 2 here. And at square root at 4, square root 5 means 2.2, as told in the last part, is 5, and here is square root 5 or 2.2. So now we will join all these points, and we have the graph of this function here. We have plotted the graph of the function here. Now we will solve the next part. It's absolute function. If there is symbol and functions like this, we will read it as absolute. This is absolute function, and in absolute function the domain is always set of real numbers, or -infinity to infinity, or capital R, as I have told you earlier that set of real numbers can be written 3 ways. In descriptive language, set of real numbers, or you can write capital R with a line, or -infinity to infinity. The domain of the absolute function is always from -infinity to infinity, and range from 0 to infinity. You have to remember it. Now we will solve for the graph. Absolute function means answer is always positive. Absolute function means all answer is always positive. Absolute make everything positive. If it is negative, answer will be positive. If there is positive, answer will be positive. Absolute function make every value positive. So these are domain and these are range. If we'll put the value of x is -3, here -3, that will be -6, and absolute of -6 is 6. As I've told you that absolute makes every value positive. So absolute of -6 is 6. If we'll put -2 here, -2 -3, that is -5, and absolute of -5 is 5. If we'll put -1 here, -1 -3, that is -4, and absolute of -4 is 4. We will put 0, 0 -3, -3, absolute of -3 is 3, and if we will put 0, 0 -3, that is -3, and absolute of -3 is 3. If we will put 1, 1 -3, -2, absolute of -2 is 2. If we will put 2, 2 -3, -1, absolute of -1 is 1. If we will put 3, 3 -3, that is 0, absolute of 0 is 0. If we will put 4, 4 -3, that is 1, absolute of 1 is 1. And if we will put 5, 5 -3, that is 2, absolute of 2 is 2. Absolute make everything positive. Now we will see that you can put lot of values after 5, there is 6, 7, 8, so on, that is infinity, and before -3, -4, -5, -6, -7, and up to so on -infinity. Here we write the domain from -infinity to infinity, and the range is always positive. As you see that the answers are positive and the minimum value is 0, and after that 1, 2, 3 there will be positive answers, and I am giving the proof that domain is from -infinity to infinity. The putting values are domain and the answer are range. The minimum value is 0, and after that there is 1, 2, and there are so many values, that is 0 to infinity. We have range. Now we'll plot these values on the x-axis and y-axis. This is x-axis and this is y-axis. Now we will plot these values at -3. This is -3, there is 6, so we'll put a point here, and at -2 it is 5, -2 and 5, we have point plotted here. At 0 it's 3, and on axis the value is 0. So at 0 we have plotted a point 3. Now at 1 there is 2, here is value of y is 2, and here is x, value of x is 1. So we have plotted a point here, and at 5 there is 2, here is 5, and here is 2. We have plotted this point. At 4 there is 1, here is value of x is 4, and here is 1. So we have plotted a point here, and at 2 it's 0, here is 3. At 3 it's 0, here is 3, and on any axis the value will be 0. So value of y is 0, so value of y is 0 here, and value of x is 3, and value of x is 3 on x-axis. So we have plotted the point here. Now at 2 there is 1, it's value y is 2 and value y is 1. So we have plotted a point here. Now we will join all these points and we have the graph of this function. Now we will solve the next part. It's piecewise function. Piecewise function means if there are pieces, it's piecewise function. There are two pieces of a function, so it's piecewise function. X is less than or equal to -2 and x is greater than or equal to 2. These are domains. It means this function is defined for x is less than or equal to -2 and this function is for x is greater than -2. So we'll put values of x is less than -2 in this function and the value of x is greater than 2 in this function. Its domain, and we have to follow these. If there is no domain written in the function, we have to follow ourselves, but if there is a value given in the question, the value of x, its domain, and we have to follow this. Now we will make a table, and after making a table we will tell you the domain and range of this function. If we will put -2 in this function, as there is written x is less than or equal to -2, so we will put values of x equal to -2 and less than -2 -3 and less than -2 it is -4. We can put 3 4 values. As many values you will put in this function, you will get better graph or better domain and range. You will understand. You can put -5 as well. If you will put -2 in this function, the answer will be -5. We'll put -3, answer will be -11, and these are domain and these are range. If we'll put -4, answer will be -17. If we'll put -5, answer will be -23. And this is function for x is greater than -2, and greater than -2 means -1, 0, 1, 2, 3. You can put as many values as you can. If you take as many values, you will get the brief answer of domain and range, and you will get the brief graph of this function. Now we will put these values in this function. If we will put -1 here, answer will be -4. If we will put 0 here, answer will be -3. If we will put 1 here, answer will be -2. If we will put 2 here, answer will be -1. If we will put 3 here, answer will be 0. If we will put 4, answer will be 1. Now we will draw the graph. At 4 there is 1. As earlier I have told about the graph and make some graph for you, but I am explaining in detail again. At -2 here is -5. The value of x is negative on the left hand side. Here is -2, and at -2 it's -5. It's -5, so we will mark a point here. And at -3 there is -11, and the value of y is minus 11, so value of y is minus 11 here, and the value of x is minus 3, it's minus 3 here. So we have plotted a point here. As I've told you earlier that if you have a linear function means the power of x is 1, you can put two values, it's enough. But if you will put more values, you will get better answer. If you will put minus 4, here is minus 4, the value of x is minus 4, and the value of y is minus 17, here is minus 17. So we have plotted a point here. Now we will join these 3 points. So the graph of this function is plotted here. Now we will plot the graph of this function. At minus 1, it's minus 4, here is minus 1, and here is minus 4. So we have plotted a point here. And at 0, there is minus 3. At y-axis, the value of x is 0, and value of y is minus 3. Here is minus 3, so we have plotted a point here. At 1, there is minus 2. Here is 1, and here is minus 2. Here is 1, and here is minus 2. So we have plotted a point here. And at 2, there is minus 1. Here is minus 2. Here is 2, and the value of y is minus 1, x is equal to 2, and value of y is minus 1. So we have plotted a point here. At 3, there is 0. The value of x is 3, and at x-axis, the value of y is 0. So we have plotted a point here. And at 4, answer is 1. The value of x-axis is 4. Here is 4, and the value of y is 1. So we have to join these points. So this is the graph of this function, and the graph of this function was plotted before, and this is a graph of piecewise function. As here is a break, so it is a discontinuous function. We will tell you later in exercise 1.4. Now we will plot the graph of the part number 6. Here is a function, and as I've told you in earlier that this is piecewise function. As there are two pieces, so it is piecewise function. There are two functions. One function is for x is less than 3, and other function is x is greater than or equal to 3. We will always read from this symbol x. It can be read as 3 is less than or x, but we will always read from the side x. If this is open, so we will read greater. X is greater than or equal to 3. As I've told in the last part, the values which we have to put in this function less than 3, because it is mentioned that we have to put the values of x less than 3 because the domain is given, so we have to follow this. As this is the domain, so we have to follow this. If there is not written domain, so we can put any values but if there is a domain, so we have to follow this. As I have not explained the domain. I have plotted the graph of the last part. I have to tell you the domain and the range of this question. As this is piecewise function, so we have to plot the graph first, and after this we will find the domain and range. This is domain. Before less than -2, there are -3, -4, -5 up to so on -infinity. Before -2, there is -3, -4, -5 and -infinity. So domain will be start from -infinity, and here is x is greater than -2, -2 greater than -2 or -1, 0, 1, 2, 3 and 4. This process will be continued and this will end at infinity. So domain is -infinity to infinity, that is -infinity to infinity is domain, and the answers, as you see that the values are decreasing. If we put some values in this function, you see that -5, after -5 there is -11, after -11 there is -17. This value is decreasing and it will decrease up to -infinity, and in this function you see that after -4 there is -3, -2, -1, 0, 1. This value is increasing and it will end at infinity. So range is -infinity to infinity. Range is from -infinity to infinity. Now I will explain this part. We have to put the value of x is less than 3 as it is given in the question. Before -3 there is -2. X is greater than 3. Here is x is less than -3. Here is x is less than -3. So we have to put values of x less than 3. Here is x is less than 3, so we have to put the value of x less than 3. Less than 3, 2, 1, 0, -1. You can continue and you can stop at -1 as well. As I've told you earlier that you can put lot of values, you will get better explanation about domain and range, and you will get better graph. Now if we put some values in this function, if we put -2 here, answer is -3. If we put -1 here, answer will be -2. If we put 0 in this function, we will get -1. If we put 1 in this function, answer will be 0. If we put 2 in this function, answer will be 1. Now we have to put value of x is greater than 3, greater than or equal to 3. So we have to put 3, as there is equal sign, so we have to put 3 as well. Greater than or equal to 3, we have to write 3 as there is equal sign, and greater than 3 there is 4, 5. We can stop here and we could put 6 as well. You will put 6, 7. You will get better explanation about domain and range and better graph. Now, so first of all, I will tell you about the domain. As you see that before less than 3, 2, 1, 0, -1, -3, and this process will be continued till minus infinity. And greater than 3, 4, 5, 6, this process will continue till infinity. So its domain is from minus infinity to infinity. We have written here, and we can write set of real numbers in descriptive language and in mathematical language or with a line. Now I will tell you about the range. If you put 3 here, 3 minus 1, that will be 2. As there is sign of less than, so for less than sign there is small bracket. If we put 3 here, we have 2, so we will write small bracket here, and as you see that the answer is decreasing from here. If you see that if we will put values of x is less than 3 as it is told in the given question, the answers are decreasing, and this process will continue till minus infinity, as there is 1, before 1 there is 0, and before 0 there is -1, before -1 there is -2, and before -2 there is -3. As you see that this value is decreasing, these are range, and this value is decreasing in this function, and it will continue till infinity. And if in this function you see that answers are increasing 7, 9, 11, 13, and this process will continue till infinity. And you see that there is 7 here at 3, as there is equal sign, x is greater than or equal to 3. For equal sign we have square bracket. At 3 there is value 7, so we will mark square bracket at this 7, because there is sign of greater than or equal to. At 3 there is 7, so we will mark square bracket, and after 7, as I have told you earlier that these values are increasing, this is range, and this will continue till infinity. So this is the range of this piecewise function. Now you can plot the graph as I have told in the last part number 5. You can make it very easily. For this function, this is the graph, and for this function, this is the graph. For this function, here is the graph, and for this function, here is the graph. Now we will start the next function. This is the rational function, and here domain is given, so we have to follow this. If we can simplify this rational function, we have to simplify it first. As you see that you can make pairs of, or you can Meltdown break of this function x square plus 3x plus 2. Meltdown break of 3x is 2x plus x, and we can write x square plus 3x plus 2 as x square plus 2x plus x plus 2. If we will take x common from first two terms, it will be x into x plus 2. If we will take 1 common, it will be 1 into x plus 2. Here x plus 2 is common. After we will take common x plus 2, we have x plus 1, and x plus 1, that was the divisor, we will write till end. Now x plus 1 will be cancelled and we have x plus 2. We have simplified. Now we can make the graph, and we can learn the domain and range very easily. As I've told you that if this is given in the question, this is domain, its domain. X is not equal to -1, this is domain. It means set of all real numbers except this value. Not equal means this is not included in the domain. All real numbers are included, but this number is not included. Not included means we have to subtract. So we have write or -1 as domain. In descriptive language, I have told you that all real numbers except -1, because x is not equal to -1. This means this is not a domain. Except this value, all are domain. Now, if this is not domain, its answer not will be range. As x is not equal to -1 is domain, so its answer will not be in range. We have a function g of x is equal to x plus 2. If we will put -1 here, -1 plus 2, that is 1. This means if x is not equal to -1 is not a domain, the answer will not be in range. So set of all real numbers except x is not equal to 1. Set of all real numbers except x is not equal to 1, that we have to subtract 1 from set of real numbers. If we will put some values in this function for the graph, g of x is equal to x plus 2. If we will put -2, answer will be -1. This is a linear function. You can put 2 or 3 values I have told in the first part, but if we will put some values, we will get better graph. If we will put -2 here, answer will be 0, and if we will put 0, answer will be 2. If we will put 1, answer will be 3. If we will put 2, answer will be 4. Now we will plot the graph. The value of x is -3, here is -3, and value of x is -1. Value of y is -1, here is -1. So we have plot this value here. At -2, there is 0. The value of value of y is 0, so it's on x-axis. At x-axis there is -2 and 0 is here, so we have plotted the point here, and at x is equal to 1, here is x is equal to 1, and the value of y is 3, and here is 3, so we have plotted point here. At x is equal to 2, there is 4, the value of x is 2, and a is value y is 4. So we have plotted a point here. Now we have to join these as it is given that at x is equal to -1 there is no domain, so we will not make a graph at x is equal to -1. As domain is not x equal to -1, so we will not plot graph at x equal to -1. You see that there is empty space. At x equal to -3 and x is equal to -2 and x is equal to 0, we have plotted these points and we will join these points. But at x is equal to -1, that is not a domain, so we will not plot the graph here. And after that there is 1, 2, and you can put 3. There are some values, so we have plotted the graph here. Now we will solve the next part. It's not a continuous function. As I've told you earlier that if there is a break in graph, it's not a continuous function. We will tell you in exercise 1.5. This is the last part, that is part number 8. This is a rational function. First of all, we will check whether it can be simplified or not. We can simplify x square minus 16, that is a square minus b square. 16 square can be written as 16 can be written as 4 square. So x square minus 4, that is x a square minus b square, and a is x and b is 4. So a plus b, that is x plus 4, and a minus b, that is x minus 4, and x minus 4 will be written same like this. And after applying the formula, x minus 4 will be cancelled and we have x plus 4. As it is given in the question, and this is domain, this is x is not equal to 4, as I've told in the last part that except x is equal to 4, all values are domain. I have written in the red that all real numbers except 4, because x is not equal to 4 is domain, so we have to subtract this from the real number set, that is r minus 4 in this curly bracket. All real numbers except 4, as x is not equal to 4 is the domain, so we have written the domain. And we have a function g of x is equal to x plus 4. If we will put 4, that is 4 plus 4, that is 8, the answer will not be in range, so we have to subtract 8 from the real number, and range is all real number except 8. I have told you the graph of rational function in the 7th part, but I will explain it again so you can understand it deeply. If we put some values in the function, that is gx is equal to x plus 4, if we put minus 4, answer is 0. At minus 3 there is 1, at minus 2 there is 2, at minus 1 it is 3. You can put 4, 5, 6 values. It's a linear function. You can put only 2 points, you can get a graph, but remember that this is a domain, that is x is not equal to 4. If domain is given like this, x is not equal to 2, x is not equal to 4, you have to put 5 or 6 values. If this domain was not given in the question, You can put 2 or 3 values, but if there is a domain given like this, x is not equal to 2, x is not equal to 3, x is not equal to 4, you have to put 5, 6 values at least. As I've put some values in the table and we have some values, these are domain and these are range, so we will plot these values. At minus 4, the value of x is minus 4 and the value of y is 0. Here is value y is 0. At x-axis value y is 0. At minus 3 it is 1. So we have plotted a point here. At minus 2 there is 2. So we have plotted a point here minus 2 and this is 2. And at 0 value of x is equal to 0, so it will be on y-axis. At y-axis it is 4 and the value of y is 4 here, so we have plotted a point here. At 1 there is 5, the value of y is 5 and value of x is 1, so we have plotted a point here. The value of x is 2 and the value of y is 6 and value of y is 6 is here and value of x is 2 is here, so we have plotted a point here. Value of x is 3 and the value of y is 7. This value of x is 3 and this is 7. So value of x is 3 here and the value of y is 7 here, so we plotted a point here. The value of x is 5 and the value of y is 9, so value of y is 9 here and value of x is 5 here, so we have plotted a point here. Similarly at 6 there is 12, so we have plotted a point here. Now we will join all these points, but remember that if there is domain that is x is not equal to 4, so there will be no graph at x is equal to 4, so we will some empty space here. As you see that this is x equal to 4 and we have some empty space here because x is not equal to 4 is domain, so we cannot put a graph here. This is a discontinuous function as told in the last part. If there is a break, it is a discontinuous function. Now I'm going to start the next topic, that is without finding inverse find the domain and range. Without finding inverse find domain and range. This is question number 3, exercise 1.2. In exercise 1.1, we have a given function and we have to tell the domain and range of that function. But in this question, we have given f of x, but we have to tell domain and range of f inverse. Is f inverse not given? Inverse function is not given. Without finding inverse function, we have to tell domain and range of f inverse x. F inverse x is not given, but we have to find domain and range of f inverse. Given function is f of x. You will remember this thing that domain of f inverse of x is range of f of x and range of f inverse of x is domain of f of x. That is, domain will change into range and range will change into domain if the functions are inverse of each other. If functions are inverse of each other, the domain of f inverse of x is range of f of x and range of f inverse of x is domain of f of x. So we can find the domain of f x and we will follow this rule, we can get domain and range of f inverse of x without finding inverse, as it is told in the given question that don't find f inverse of x. Some people find f inverse of x and after finding they will write domain and range. It's wrong because he has forbidden to find f inverse x. As I've told you in the last question that square root is always positive. So square root of x plus 2 is positive. If we take squaring on both sides, we can write x plus 2 is greater than or equal to 0. If we'll take 2 on the right hand side, it will be x is greater than or equal to minus 2. We have written x is greater than or equal to minus 2. Greater than minus 2 means greater than or equal to. Equal means we have to mention in the square bracket. Greater than minus 2 means minus 2, minus 1, 0, 1. This process will continue till infinity as I've told in the last question. So domain is from minus 2 to infinity, and now we will find range. If we'll put 2 in this function, 2 plus 2, that is 4, square root of 4 is 2, so range is 2 as it is a symbol of equal, greater than or equal, so we have to mark a square bracket. The range is at minus 2, if we'll put minus 2 here, minus 2 plus 2, that will be 0, and we have to put square bracket as there is a symbol of equal. As there is a symbol of equal, so we have marked square bracket here, and after this, I have told you earlier that the range of square root function is always from 0 to infinity. In the last question, in part number 2 and part number 3, I have discussed earlier that range of square root function is always from 0 to infinity. Infinity is not a number, so we will mark a small bracket, and 0 is a number, but as there is equal symbol, so we will write square bracket here. We have find the domain and range of f of x, but we have to find domain and range of f inverse of x, as I've told that domain of f inverse of x is range of f of x, and range of f of x is 0 to infinity, and range of f inverse of x is domain of f of x, and domain of f of x was minus 2 to infinity. This is the part number 1. Now I will tell you about the second part. Before going to solution of the second part, as it is written in the given question, without finding f inverse of x, find domain and range of f inverse of x. Most people find f inverse of x, then they write domain and range. It's wrong. Here is a technique. As there is a function x minus 1 in numerator, so we will make it 0. X minus 1 is equal to 0, that is x equal to 1. we have to remember this value. This is range. This value is not a range. If we will put x minus 1 is equal to 0, answer will be 1. This is not a range. So we have write r minus 1 because this is not a range. So accept all real numbers except x is equal to 1. So we have subtracted 1 from real numbers. It is range. But domain, if there is a function and there is written x is not equal to 4, as I've told earlier that its domain, if there is written x is not equal to 4, it's a domain. It means all real numbers except 4, that is we have to subtract 4 from the real numbers. We have find domain and range of f of x, but we have to find domain and range of f inverse of x. So we will subtract from, so we have to follow the rule that domain of f inverse of x is range of f of x, and range of f of x was all real numbers except 1 or real numbers minus 1, and range of f inverse of x is domain of f of x, and domain of f of x was r minus 4, and we have find the domain and range of f inverse of x of the second part. Now we will find the domain and range of part number 3 and part number 4. Here is again a rational function, and remember that if there is written without finding inverse function, you have to follow this technique that is told in the part number 2, that if there is a rational function and there is written without finding f inverse of x, write the domain and range of f inverse of x. We will follow this rule. I will tell you, x is not equal to 3, that means minus 3 is not a domain set of all real numbers except minus 3. So we have to subtract minus 3 from set of real numbers. This is domain of f of x, and as I've told in the last part, here was x minus 1, we have put is equal to 0, but here is not a variable x in the numerator. If there is no number in the numerator, we will subtract 0 from set of real numbers. If there is a variable x minus 2, we will make it 0. So x is not equal to 2 is the domain, but if there is not x, it can be 1, 2, 3, 4 positive number or negative number, minus 7, minus 6, it can be any number. If there is any number without an variable, we will subtract 0 from the real numbers in the range. This is the rule if there is written without finding f inverse of x, write the domain and range. But if there is a function given and we have to find the domain and range of that function, we will not follow this rule. We will follow this rule if there is written without finding inverse function, find the domain and range. Now we have find the domain and range of f of x, but we have to find domain and range of f inverse of x. As I've told you the rule that domain of f inverse of x is equal to range of f of x, and range of f of x was r minus 0, and range of f inverse of x is domain of f of x and domain of f of x was the r minus minus 3. Now the last part, that is part number 4, here is again x is greater than or equal to 5. This is domain. It means we have value 5 as it is equal, greater than or equal, we have 5, there, after 5 there is 6, 7, this process will continue till infinity. So domain is from 5 to infinity. 5 is included as there is symbol of equal, so we will write square bracket and till infinity. Infinity is not a number, so we will put small bracket. This is domain of f of x, and if we will put 5 in the given function, 5 minus 5, that will be 0, and square of 0 is 0. So minimum answer is 4, 0. At 5 there is 0, and 0 is range. And after that, if we will put greater than 5, 6 minus 5 square, that is minus 1 square, that is 1. If we will put greater than 5, that is 7 minus 5, we have minus 2 square is 4. You see that the value is increasing. At minus 5 it was 0, and at minus 6 it was 1, and at minus 7 it was 4. You see that this value is increasing, and this will continue till infinity, so its range is from 0 to infinity. This is domain and range of f of x, but we have to find the domain and range of f inverse of x. We have follow the rule that domain of f inverse of x is range of f of x, and range of f of x was 0 to infinity, and range of f inverse of x is equal to domain of f of x, and domain of f of x was 5 to infinity. That is, then at the last I will say that again, that please subscribe and share my YouTube channel with others, that so that I can make lot of videos for you, and you learn that mathematics is really easy subject. It is not a difficult subject. If you have any problem, you can contact at my Gmail address, zafeermath@gmail.com, at hotmail.com, at Instagram. I'm famous with Zafeer Math. You can contact me at Gmail, Instagram, Facebook if you have any problem. Jazakallah.